Okay, so these are just three possible answers that work for this. I can plug in as many x values as I want. I can keep getting different y values. Now, it's not all real numbers because each solution has two parts to it. Okay, x could be anything, but it's got to team up for y. It's not all real numbers because it can't just plug in any numbers, but there are an infinite number of combinations that would work. So what is the difference? Why does this only have one solution and this has infinite solutions?
There's two variables.
Yeah, this one has one variable, so there's only one thing it could be, which is 6. So one number answered. This is two variables, and there's an infinite amount of combos that would work. So as x goes up 1, y is going to go up 2. Anyway, it's I think it was chapter 6 that we graphed these. You guys remember graphing these? You go down 5 and then up 2 and over 1. And you guys remember graphing those? All those points on this graph, remember, they represented a solution for this equation. Like this point right here is like 1, -3. That's one of the solutions for this equation. All these infinite points represent the infinite solutions that work in this equation. Got it? That was all review so far, hopefully. You guys remember all that? Kind of. Let me go to another page. How many solutions does that have?
Infinite.
Infinite.
Let's go.
How many solutions does that have?
Infinite.
Infinite. How many solutions do you think that they have in common?
A bunch. Cause they're like,
Almost every number.
Okay, let's graph it. If I go down 2, and then where do I go from there? Rise -1, run 1. You guys remember doing this?
let's go down.
Down 1, right 1. Down 1, right 1. So it looks something like this. A pretty rough sketch here. And then on this one, I start down 4. And then I go, where do I go from there?
Up 1.
Up 1, right 1. Up 1, right 1. Up 1, right 1. So it looks kind of like that.
So 1.
Okay, so if all the points on this line represent the solutions for this equation, and all the points on this line represent the solutions for this equation, how many solutions do they have in common? 1. This point right here represents the solution that would work in both equations. What is this point right here?
Intercept.
1, -3. So if I graphed it correctly, if I wasn't too sloppy, 1, -3 should be a solution that works in both of these.
Yeah.
So if I plug in 1, for example, that would be -1 times 1 is -1 minus 2 is -3. You guys see what I'm saying here? If I plug in 1 and -3, I get -1 minus 2, which is -3. Same thing down here. If I plug in 1 and -3, you get 1 times 1 is 1, minus 4 is -3. So you see how it works in both equations? It's a common solution. So normally when two lines are on the same plane, they're going to intercept each other once. So there's usually going to be one common solution between two linear equations like this. And that's what we're going to be finding today. When you have more than one equation that you're trying to solve at the same time, they call it a system of equations. Okay, so it could be more than two, but really we're only going to do 2 at a time in this chapter, Algebra 1 really. So a system of equations where when you're trying to find the solution that works in all the equations at once. Usually there's going to be one. Can you guys think of a graph where there's not going to be one? Right, if the lines were parallel. You guys remember what we knew about slopes of parallel lines?
Exactly this.
Yeah, if they have the same slope, so maybe like one of them is y equals 1/2 x minus 4, that would be the slope. And another one is y equals 1/2 x plus 3. These two would be parallel, and they would have no common solutions. Something like this. So if they ask what the solution was, it would be no solution. But they have to be perfectly parallel for that to happen. Another weird case is if you graph the line and it turns out to be like the exact same line both times. So in that case, how many common solutions do they have? Infinite. Yeah, all the solutions in one equation are the solutions, but there's also an infinite number of not solutions. No, it's not all real numbers. Why is it not all real numbers? Because, well, each solution has to go with the right combo. Like whatever the x is, the y value has to match it. So all these things out here that are not on the line are not solutions. Or out here, wherever. So there's an infinite number of things that don't work, even though there are an infinite number of things that do work. Is that blowing your mind?
Yeah.
Also, it's not all real numbers, not only because there's two different numbers that have to work together, but because all these possible not answers. Anyway, so what I think what the book does for this is just write the equation of the line, because whatever the answers to that equation are the answers. But I think what I'm going to have you guys do is write not all real numbers, but infinite solutions. That doesn't mean every solution will work, it just means there's an infinite number of solutions that will work. Like something like this. It goes on forever. Alright, anyways. Blah, 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 blah. Talk that to death. Let's jump in. Page 281. You guys ready? The graphs begin on number 15. So that's, if you want to use normal paper before that, it's fine, or whatever. Okay, number 1, identify the solution to each system from the graph. If the solution is the line, state the line's equation. So, number 1, what is the solution for those two? 1, 5. Yes, it's where they intersect at. They intersect each other at 1, 5. That means if we solve the equations, 1, 5 would be an answer for both of them. Okay, number 3. What is the common solution for that graph? Green?
0, the 1 through.
In other words, what?
What? No solution.
No solution.
I know.
Because the lines are parallel, they will never touch each other, they will never have a common solution. So, yeah, the symbol for no solution is a 0 with a slash through it. Okay, on number 4, what's the common solution for those two lines? Right, there's an infinite number. So the book wanted you to write the equation of the line, like slope and intercept and all that stuff. But it's okay, I'm just going to say it's okay to put infinite solutions. Okay, number 5, determine whether negative 2, 5 is a solution to the system. How do we know if negative 2, 5 is a solution for the system? Plug it in. Does it have to work in both or just one of them? It has to work in both. So negative 2 is the x, 5 is the y. So does negative 2 plus 5 equal 3?
Yes.
Yes, so it works in the first one. And the second one, does 2 times negative 2 plus 5 equal 1? 2 times negative 2 plus 5 equal 1, question mark. 2 times negative 2 is
-4.
plus 5. Eh.
One.
Negative 4 plus 5 is 1, so does it work?
Yeah.
Yeah, so 5, yes. Negative 2, 5 is a solution.
You see that?
Okay, number 7. Same thing, does negative 2, 5 work? So, negative 2 goes in for x, 5 goes in for y. Does negative 2 minus 5 equal 7? No. Negative 2 minus 5 actually equals negative 7. So that's not equal, so we don't really need to check the other one. That's going to be not a solution for that system. Number 9, kind of the same thing for number 9, but they're just going to give us a bunch of different x and y's to plug in, determine whether the given ordered pair is a solution. So on 9 we're plugging in 2 and negative 5. So does 2 plus 3 times negative 5 equal 13?
No.
Yeah, that would be 3 times negative 5 is negative 15, plus 2 is negative 13, right? So this would be a no-go. So we don't really need to check the second line on this one. That would be a no. Number 11, we're supposed to plug in negative 3, negative 2. So it would be negative 3 plus 2 times negative 2. Does that equal 1? That would be 2 times negative 2 is negative 4. Negative 3 plus negative 4 is negative 7. So yeah, that's not equal. So that would be a no. They're being nice and making the first one not work for us. Number 13, I think we're doing a yes, aren't we? It's 6 and negative 5. So does 5 times 6 plus 6 times negative 5, does that equal 0?
Yes.
Yeah, that's 30, that's negative 30, and yeah, that does add up to 0. And then we gotta check the second line now. So does 2 times 6 plus negative 5, does that equal 7?
Yeah.
12 minus 5 is 7, yeah, that's true. So it works in both of them, so that one is a yes. Okay, 15 is actually graphing, so we need to get that graph paper out. And do a little work here. Okay, you guys remember how we graphed that? Y equals negative x plus 5. Where do I start at?
5 up.
Up 5, right there. So dot. And then where do I go from there? Okay, what's my slope?
1 over 1.
Negative 1
Over 1.
over 1. So I'm going to rise negative 1 and run positive 1. I'm going to go down 1, right 1. Down 1, right 1. It's kind of neat to be, kind of important to be neat on these problems because the answer is where the lines cross at. So if your lines aren't straight, you might get the answer wrong. The other one is y equals x minus 1. So where do I start at?
Down 1.
Down 1, and where am I going?
1.
Slope is 1, so rise 1, run 1. Rise 1, run 1, rise 1, run 1. So what is the common solution? 3, 2. If I'm not sure that's right, how could I check? How do I know for sure?
Put it in the problem.
Yeah, if it works as a solution to both these equations, you know it's right.
Do you want us to write this, yeah.
3, 2 is actually the answer. This is just helping us, this is more like the work. Although I am going to give you points for the graph. But 3, 2 is actually the answer. Not the graph. 17, y equals negative 6x plus 7. Where am I going to start at?
7 up.
Up 7, so make sure your graph goes up to 7. If you don't want to make a huge graph, you can make your x-axis lower, so it won't be as hard to get up to 7. Let's see, the other one says y equals 1. Okay, so I'm going to start up at 7. Where am I going to go from there?
-6 over 1.
Right. I'm going to rise -6. I'm going to run 1. So in other words, I'm going to go down 6 and right 1. So 1, 2, 3, 4, 5, 6, 1. 1, 2, 3, 4, 5, 6, 1. Okay, how do we graph y equals 1?
One.
Okay, you go up to the y-axis to 1, and you draw a horizontal line.
Yeah, horizontal.
I have a feeling we didn't necessarily do too great on the test. You go up to the y-axis to 1, and then just draw a horizontal line through that. So what is the point of intersection? 1, 1. That's where the cross at. That's the common solution. You plug it in the top one like normal if you want to check it. To check it on the bottom one, it just means the y value has to be 1, which it is. What is different about 19?
Oh, they're not in slope.
We actually
Right, they're in standard form, not slope-intercept form, so we're going to have to change its slope-intercept form to help us graph it. So what's the first step?
Subtract 4x.
Minus 4x. Got to get the y by itself. Minus 4x.
You just.
Instead of doing 7 minus 4x, I'm going to put minus 4x plus 7.
Can we just?
So it's in slope-intercept form.
Do we have to work it out? Can we just put it?
Oh, I don't care.
Okay.
Then on the other one, it's x minus 3y. This one's a little trickier, so you might want to write some stuff down. What should I do on that one?
Minus x.
Minus x. So I'll call it minus x plus 18.
4
Divide by
negative
-3.
Divided by negative 3. So we're still trying to get y by itself, so we gotta get rid of the negative 3.
And so that would make it x, like, x and
Okay.
3.
3x.
Remember there's an invisible 1 right there.
X.
So what's negative 1 over negative 3?
Positive 1.
Positive 1/3.
Minus.
Positive 1/3 x. 18 divided by negative 3 is negative 6. Okay, so here's my top equation. Let's start with that one. Where am I going to start out at? Up 7, so I'll put a dot up there. I'm getting warm finally.
He says cold or cold.
Stop.
He says what?
Toes.
Toes are cold?
Yeah.
My grandpa's does.
Ancient, man.
Like you.
Next time, I will just remind you.
Oh, they like fungusy. They're like sooty warm.
At least I know.
Okay.
Toenail looks like wood.
That's nasty.
Like wood. Just gonna
Stop that, baby, stop that.
No, my grandpa's toenail's like green.
Okay.
Just stop talking.
Negative 4 is like a negative
Down.
4 over 1. So we're going to go rise negative 4, run 1. 1, 2, 3, 4, 1.
So,
7th grade, one of my big toenails fell off.
What?
That is
My
my
middle
sister's
fingernail fell off
pinky toe.
too. David squished it in the door. It like started swelling and then it fell off. That's lovely.
That is
Yeah.
nasty.
Okay.
There's like this black stuff.
On this one, we're gonna start down at -6, so that'll be right there. And then I'm gonna rise 1 and run 3. It's not hitting very well. I think my line curved. I'm guessing it was supposed to. I think it was supposed to hit right there. Okay, so it looks like 1, 2, 3, 1, 2, 3, 4, 5. Looks like 3, -5. But since my lines weren't very straight, it was a little bit off. But how could I tell, make sure that's right?
Plug it in.
Plug it in. So if I put 3 right here, that'd be -4 times 3 is -12, plus 7 equals -5. Or if I put in 3 times 1/3, or I could put it in here. 3 minus 3 times -5, -3 times -5 is 15, plus 3 is 18, so that works. Okay, so it is 3 -5. Okay, one more, 21. Says x plus 2y equals 10.
Or graphing 21 as well.
All these problems are graphing, yes. What should I do first?
Minus
Minus x.
That's how we usually.
No, it doesn't. You should know.
Divide by 2.
One half.
Okay, right, there's an invisible 1 there, so that's -1/2 x plus 5. What's the other one say? 9x plus 2y equals -6. So, subtract 9x, huh?
What's the lowest grade on the final?
I don't know.
Do you think
Probably
he just
not.
like stares at them like,
If-
I think you're the lowest.
If I had graded it like yesterday, I probably wouldn't know that answer.
See.
But even if I did know it, I wouldn't say it.
You sound like Skylar. I think she's cracking me open.
Just kidding.
Okay, so we gotta divide by 2 again. And what is 9 divided by 2?
-9/2.
Yeah, you can leave it like that.
Wow.
And
So
-6 divided by 2 is -3. So we got that one and that one.
It's too much work.
Yeah, it's a lot. That's why we're only going to 22. There are other ways of solving systems of equations besides graphing. That's what we're going to be working on the next couple of weeks. They are better than graphing. They're more efficient than graphing.
Why is there Russian?
That's Kenyan. Always right.
Oh.
Okay, anyways, so the top one I'm going to start up at 5. Now, if the slope is -1/2, what do I do with that negative?
You go down. You.
Okay, you can think of it as being on the top, or you can think of it as being on the bottom. But you can't make the top and bottom negative, that would be like a positive.
Yeah.
Negative by many. So we can go down 1, right 2, or we could go up 1, left 2. Remember how going backwards works on these? So usually I do this. Usually I do the first one. Down 1, right 2. Down 1, right 2.
What did you say?
Okay, where do I start on the other?
Down.
Down 3. And where do I go from there?
Up 9.
Okay, I could go down 9 and right 2, but what's the problem with that?
It's
Wait,
It'll fall off my graph. So we're gonna go the other way. We're gonna go up 9 and left 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Oh, what a coincidence. Right there.
Wait, if we only just leave it like that, cause if you put another.
Yeah, 2 dots is fine. And then where are they crossing at? 1,
Negative 2,
2, 3, 4, 5, 6.
Wait, stop.
They're crossing at negative 2. Should be on your graph. They're crossing at negative 2, 6. We didn't have any no solutions on the odds. I guess we would have had to go all the way to 29 to get a no solution. Okay, you guys got 20 minutes. That's plenty of time.
I don't need your input, baby. Why do you say
What'd you say?
be quiet? No, I didn't do that.
You get what? The whole lesson?
No, just.
Oh, you got the last one?
Yeah, they didn't